Welcome to Pre-Calculus video for skill number 9. I can solve quadratic equations by factoring, completing the square, and using the quadratic formula. Below is a map of the United States, and a rather difficult trivia question is, what do the colors represent? Alright, so the lesson, I can solve quadratic equations by factoring. So if we're going to learn how to do that, we should know what a quadratic equation is. And a quadratic equation in x is one that can be written in the form ax squared plus bx plus c. And it should be noted that a, b, and c are real numbers, and that a is not 0. If a was 0, we would just have bx plus c, and that's not a quadratic equation. So, there are common methods, 4 common methods for solving a quadratic equation. The first method is the factoring, and we should be pretty comfortable with factoring from Algebra 2, so I'm going to move through that rather quickly. There's also the quadratic formula, which I remember quizzing you guys on at the start of the year, and you seem to remember it. And then the last two, which probably are relatively new to you, are completing the square and extracting the root. Extracting the root is very straightforward, so I'm going to start with that one. I'm not going to test on it because the extracting the root is one of the steps of completing the square. So I will test on factoring, quadratic formula, and completing the square. And what I probably will do is I will give you one problem, and I will have you show me how to do it all 3 methods. And I'll probably do that twice. So the great thing is, if you're able to solve it one way, the other ways you know the answer to already, so it'll support your answers. So let's start with extracting the root. This is useful for equations in the form of a quantity, and we'll call that quantity ax plus b, and that quantity gets squared. So ax plus b squared is a number. So I showed an example here. The 2 we can shift over to the right hand side of the equation by dividing it out and get this ax plus b quantity squared equals 4. So example 1, they give us the equation and we can extract the root from here. So the first step we do is move the 27 to the right side of the equation, and then we divide by 3, and that puts us in a state that is very much like what we described as this, useful for extracting the root. The first thing we do is we take the square root of both sides, and if we do that, the square root cancels the square, and you're left with 2x plus 6, and the square root of 9 is positive and negative 3, which means either 2x plus 6 equals positive 3 or 2x plus 6 equals negative 3. And we go about solving for x, and we arrive at x equals negative 3 halves or x equals negative 9 halves. It should be noted that quadratic equations always have 2 solutions. You may have 2 real solutions, or you may have 2 imaginary solutions, which we'll talk about later. Or you may have 2 identical solutions. So those are kind of unique, but 2 identical solutions is a scenario. I'll try to avoid that one on this skill test, but we should be able to learn how to recognize it. So the next method is factoring, and factoring is useful for equations that can be easily factored. And honestly, there is no way to tell whether an equation can be easily factored until you've practiced factoring a whole bunch and get really comfortable with it. Otherwise, you're just going to kind of look at the problem and try to factor it. If factoring doesn't work for you, then perhaps a different method is better. So I gave us an example 2, solve x squared plus 3x minus 4 equals 0. And the thing that I did first was I took this form and I wrote it in the factored form. I encourage you to check out videos on factoring. I'll try to link to my video on factoring so you can brush up on that skill if you'd like. There are lots of different methods for factoring, so whatever method works best for you. Once we have it factored, we can use the zero product property, which says that if this whole equation, this whole expression is equal to 0, then at least one of the factors is equal to 0. So either x plus 4 is 0 or x minus 1 is 0. And if we solve that for x, we get x equals negative 4 and x equals 1. What that means is if we took these values and plugged it into the equation, we would get a true answer. And I'll just do that real quick with 1. 1 squared plus 3 times 1 minus 4 does in fact equal 0. 1 plus 3 is 4 and 4 minus 4 is 0. Example 3. Solve 2x squared plus x equals 21 by factoring. And this one's not in our standard ax squared plus bx plus c form, so in my first step I write it into that form, and then I factor it. And this is a slightly tougher problem to factor. Once again, check out videos on factoring if you wanted to get a refresher on the factoring process. Then we use the zero product property and say either 2x plus 7 equals 0 or x minus 3 equals 0. This yields a value of x equals negative 7/2 or x equals 3. And once again, that means if we take those values and plug it into our initial equation, we will get a true statement.
I feel.
Do you feel alive?
I feel happy of myself.
I feel happy of yourself too.
Alright, so the quadratic formula is a great form because it always works, even with irrational or imaginary roots. So there are some quadratic equations which you can't factor, and those will have irrational roots or even imaginary roots. And the quadratic formula is a good catch-all because it always works, and it's generally pretty easy to just plug values from one equation into another equation to spit out an answer. If you're interested, I have a short little video on the quadratic formula, Dr. Seuss style. Yay, Dr. Seuss. So if you want to check that out, click this link. Otherwise, let's move on to the next example. Solve 2x squared plus x minus 21 equals 0. And if you notice, this is the same problem as example 3, but I just wanted to show us using the quadratic formula for it. So the first thing I do is I write out the equation and I identify what is my a. And a is the 2 value. And my b is it's not written, but it's a 1. And then finally my c is negative 21. So we take those and we plug it into our quadratic formula. So our b becomes a 1. So what we have is negative 1 plus or minus b squared minus 4ac all over 2a. And I crunch all of that out, being careful to adhere to the order of operations and getting the two negatives become a positive and arrive at 169, and then I square root that and I get negative 1 plus 13 and negative 1 minus 13, finally arriving at the answers of 3 and negative 7/2, which confirms what I did in example 3. And this is kind of how it'll appear on the skill test. I'll give you two problems, or a problem that's identical, and I'll have you solve it multiple ways. So here we did quadratic formula. In example 3 we used factoring. So that's one example of quadratic formula. Let's take a look at a second example. Down here, example 5 says solve negative 3x squared minus 2x plus 5 equals 0. And what we've got is an a value of -3, a b value of -2, and a c value of +5. Take our quadratic formula and plug those values into the appropriate spots, simplify it all down, and we arrive at the two answers of -5/3 and 1. If we ever wanted to check our answers, and it's always a good idea to do this, then we could plug it back in. Usually I check it just to make sure one of them's right. If I have time, I'll check a second one. So let's stick 1 into the equation and see if we get the correct answer. -3 times 1 squared minus 2 times 1 plus 5 equals -3 minus 2 plus 5, which equals 0. So it does check out. Woohoo!
Got any words of wisdom? What about for all the other kids trying to learn how to ride their bike? Can you say anything to them?
Everybody, I know you can believe in yourself. If you believe in yourself, you will know how to ride a bike. If you don't, you just keep practicing. You will get the hang of it, I know it. If you keep practicing, you will get the hang of it, and then you can get better and better at it as you do it.
Give me some.
Alright, the final method is called completing the square. And this is the method that was actually used to derive the quadratic formula. So people first discovered completing the square, and then from there they're able to create the quadratic formula. So a lot of people don't like using completing the square because it is a little bit more tedious, but the important thing is it's actually useful for things beyond just the quadratic equation. One thing we've already seen this year was the general form of circle equations, the x squared plus y squared plus ax plus by plus c equals 0. And completing the square is a useful way to convert that into the other form of a circle, the standard form x minus h squared plus y minus k squared equals radius squared. And I'm not going to get into that, but it is an interesting side discovery. If you're interested, come talk to me about it. So I say that completing the square is best used for equations that are in the form of x squared plus bx equals c. And oftentimes we have equations which are close to that, and it wouldn't be too difficult to manipulate them so they are that. The process says in step 1 you want to write the equation into that form, and then step 2 we add b over 2 quantity squared to both sides, and then it factors. If we do that, we can actually factor it into the form of x plus b over 2 quantity squared, and that's going to equal the other half, which would have been c plus b over 2 quantity squared. And then from there we can solve by extracting the root. So this is best understood through examples, so let's take a look at example 6 where I walk us through the process. First, we have the equation and it says solve by completing the square. And we don't quite have the x squared plus bx equals c, but in step 1 we're actually able to do that fairly quick. Step 2 says add b over 2 quantity squared to both sides. So since b is 6, we take 6 over 2 and we square it, and we're going to add that to both sides. Some people simplify it in their head when they're writing. Half of 6 is 3, and 3 squared is 9. So we add 9 to both sides, and we get negative 8 plus 9 is 1. So a lot of people jump to solution, or this step here, and they're simplifying. But I avoided it here so we can follow it through. Factor into the form of x over b plus 2 quantity squared. So we did that here. X plus b over 2 quantity squared. And the right hand side I just carried down, but we eventually simplify it. And now we have, in a simplified state, x plus 3 quantity squared equals 1. from there, we solve by extracting the root, and that was the very first method we used. The first thing we're going to do is we're going to take the square root of both sides, and that gives us x plus 3 equals plus and minus 1. So x plus 3 either equals positive 1 or it equals negative 1, and we simplify it out and we get our two solutions. At first this method looks a little daunting, but I personally have found that of all the methods, this one actually winds up getting me to the answer the fastest, especially if the leading coefficient is a 1. So in the next example I'm going to show you a case where the leading coefficient is not a 1, and we'll work through that by using completing the square. Alright, solve 2x squared plus 5x minus 2 equals 0 by completing the square. The first step was to write the equation in the form x squared plus bx equals c. So the first thing I did was I moved the 2 from the left side of the equation to the right side by adding 2 to both sides. And then I eliminated the leading coefficient by dividing everything by 2. So the 2 goes away here, 5 divided by 2, and then 2 divided by 2. Now we're in the form that's desired for step 1, so we can go about carrying out completing the square. The first thing we do is we take our b value, this 5 over 2, and we cut it in half and square it. And we add that to both sides. Cut it in half and square it. Then we factor it into the form of x plus b over 2, and we take that whole quantity and we square the quantity. The right side I didn't simplify at all until the next step, and the next step I simplified the right hand side. And now what I have is an expression that I can solve by extracting the root. The first thing I did was I square rooted both sides, and that took away the squaring and gave me x plus 5/4 on the left side, and then plus and minus root 41 over 16, which I then simplified by taking the square root of the denominator, and I went through and solved it out, arriving at the final answer of x equals negative 5 plus or minus root 41 over 4. Now naturally this is a difficult example. It's more difficult than I would expect of you on the skill test, but it really demonstrates all of the little kinks that exist within completing the square and why the other forms are sometimes preferred. So perhaps for this example the quadratic formula would have been the fastest possible way.
Thumbs up, everybody!
All right.
For rock and roll!
So this concludes video for skill number 9, and featured below is a map of the United States, and we're asked, what do the colors represent? They represent the generic term for a sweetened carbonated beverage. As you can see over here in Oregon, most people say soda and pop, whereas down in the South we've got a lot of people who refer to all beverages as Cokes, or maybe soft drink. What do you use?